This lesson is going to be on hydrates and calculations that we can do for different hydrates. So the calculations are very similar to the ones that you've already learned about, like percent composition and empirical formulas. We're just going to apply them to a hydrate. So remember, a hydrate is just an ionic compound that has water kind of trapped within the substance or within the crystalline structure. So this first set of calculations is we're just going to determine the percent of water in the compound. And we do the same thing here that you do in any other percent calculation problem, right? So just like you're trying to find the percent you made on a test, you take your number of questions you got right out of the total number of questions. So we're going to take the mass of water out of the mass of the total mass of the salt. So I'm going to go through and just add up the mass of each component of my compound. So I have 1 magnesium. So I'm just going to write down the mass of 1 magnesium, 24.31. And then I have chlorines, but I have 2 of them. So I'm going to have to multiply that by 2. Then when I get to my water, this 4 in front, what that's saying is that I have 4 molecules of water. So when I add up my hydrogen, I'm not just going to have 2 like in a water molecule, but I'm actually going to have 4 times 2. So you end up with 8. And then with oxygen, same thing. I have 4 times 1. So we'll have our 4 oxygen atoms times the mass of 16, because that's 1 oxygen has a mass of 16. So I'll just kind of go through and multiply these all out. So I end up with all of my different components. Okay, and then now I can kind of total everything up. And so let me grab my calculator here, and then you can kind of add yours up along with me. Double check my math. So the total here is 167.29 grams. So this is my total mass here. Okay, so I know that that's going to go on the bottom of my equation. And then I'm really just concerned about the mass of the water. So I'm not really looking at magnesium and chlorine right now, but I'm just looking at my hydrogens and oxygens. And so I'm going to add those 2 up so that I get just the mass of water, which is 72.08. So now, when I plug that in, I end up with 0.431. And then I know to get a percent, I have to multiply it by 100. So I end up with 43.1% H2O. Okay, so you have 2 other practice problems here that you could work out. Remember, when you're adding everything up, this 5, remember it's saying I have 5 molecules of water. So you don't just have 2 hydrogen atoms, you have 10 hydrogen atoms. Okay, same thing here. You have 4 hydrogens and 2 oxygens, sorry. And then you have your answers here, so you can kind of check and see if you're on the right track after you solve them. The next type of calculation we're going to do is to determine the empirical formula of a hydrate. Okay, so remember, this is kind of like what we did in the lab, or what you're going to do in the lab. And for those calculations, so like, for example, if we look at this problem right here, we have a sodium chloride hydrate. Okay, so I know that the first part of my formula is just NaCl. So what I'm really trying to find here is this question mark. I'm trying to determine the mole ratio between my water, the hydrate, and the actual ionic compound. So I know that this is going to be 1 because it's always, this number here in front of my water is always in relation to 1 mole of my salt. So the first step is I have to figure out how much water and how much salt I actually have in this compound. Okay, how much of the compound is made of salt and how much is made of water. So I can just look at my data. So a 4.5 gram sample is heated, and then after driving off the water, the salt is 2.78. So I know that my anhydrous salt is 2.78 grams. Okay, so I have 2.78 grams of NaCl. I can also figure out my water because it says I start with 4.50 grams. And if I'm left with 2.78, that means that the amount of water that evaporated was 1.72 grams. Okay, so remember, I can just subtract what's left from the original amount to determine how much water was evaporated out. Okay. Next, okay, if we kind of think back to our empirical formula, right, we have that nice little saying that we can say to help us calculate our empirical formula. And it goes like percent to mass to mole, and then divide, by small, and then multiply till whole. So I didn't start with percent, I actually started with mass, so we're good there. So my next step is to go from mass to mole, okay? Because remember, these numbers, it's a mole ratio, so I have to compare my amounts in moles. So I'm just going to set up my dimensional analysis. Okay, remember, I can go from, if we think about our little mole map, let me kind of write that up here. We can go grams to moles to atoms, remember? Okay, and I'm not really worried about this atom side right now. I'm really worried about this right here. I'm trying to go from grams to moles. So I know I need to use molar mass. So I'm going to look at my periodic table, and I'm going to find the molar mass for NaCl. So sodium is 22.99. Chlorine is 35.45. So when I add those up, I get 58.44 grams. And notice I put it on the bottom so that my grams cancel out. And then on the top, I'm going to put 1 mole, right? Because my grams are always equal to 1 mole. I'm going to do the same thing with water. So I'm going to add up my water. Okay, so my grams cancel. So when I plug this into my calculator, when I divide the top by the bottom, I end up with mole NaCl. And then this one, my water is 1.72 divided by 18.02. I end up with 0.0954 moles H2O. Okay, so now that I've done mass to mole, my next step, divide by small. Okay, so what is my smallest number here? Well, my smallest number, I'll kind of change colors, is my moles of NaCl. And remember, this kind of tracks with what we were saying, right? We want to look at our moles of water compared to our moles of NaCl. So I'm comparing mole of water on top to my moles of NaCl. So this is how I'm getting to that mole ratio. So when I divide, that's going to equal 1, and then this one essentially equals 2. Okay, it's really close. I think it's exactly like 2.004. Okay, so remember, we want to round to a whole number. So when we think about normal empirical formulas, these would normally be our subscripts. But when we're talking about a hydrate, these numbers now become our coefficients, or the number right in front. So we know that NaCl, we wanted it to be 1, which it is. And then now my number that goes in front of my water is a 2. Okay, so if I wanted to name this, it would be sodium chloride, because remember I just named the ionic compound, and then I use a prefix dihydrate. Okay, so if you want to, I will work this last one on this video, this extra practice. I suggest that you pause the video or stop the video and then try it yourself, and then come back and watch me work it, or if you don't get the right answer. Okay, so I'll kind of work out the problem that way. If you don't get the answer the first time, or if you want to see one more example, you can watch this one. Okay, so I'm just going to kind of work through it kind of step by step. So 210.4 gram hydrate. Okay, so that's my total amount. Was heated. The final salt was 120. So my salt is 120.4 grams, and that's of my magnesium sulfate. Okay, water. Remember, I'm going to subtract the 210 minus the 120 because I want to get just the amount of water that was evaporated off. So I'm just going to subtract those in my calculator, and I get 90 grams of water. So now that I have my grams, I need to convert to moles. This is going to be a little bit tight on space down here, but I'll kind of squeeze in the numbers. Okay, and then I'll have to add up the molar mass for magnesium. So we have 24.31 for magnesium, and then sulfur is 32.07. And then I have 4 oxygens, so I have to add 16 4 times. So I end up with 120.38 grams, and that's 1 mole. So essentially, I have 1.00 mole of magnesium sulfate, and then 90 divided by 18.02, this is 4.99 moles of water. So now, the next step, I have the moles, right? And this is just the mole ratio. How many moles of water compared to 1 mole of magnesium sulfate, sorry. So, I can divide by the smallest number, which is 1. Okay, it's just going to give me the same answer. So for magnesium, I have 1. And then remember, I want to round to my nearest whole number. And so that gives me 5 for water. So remember, when I write my formula, this 1, right, is next to magnesium sulfate, but it's invisible. So I'm going to erase it because we don't normally write that. And then, sorry, give myself some space. We have our hydrate function. And then remember, this number, this 5, is what goes in front of the water, or the hydrate. So this would be magnesium sulfate pentahydrate. So hopefully that helped. Like I said, it's very similar to solving for regular empirical formulas. So as long as you can kind of remember this little saying here, then you can solve a million of these because you just go step by step every time.